Did you know that 80% of enterprise data is largely unstructured? And 70%, a large percentage of it, is in the form of free-form text. By free-form text, I mean we see a lot of enterprises sitting on dark data. And this data can be a document goldmine. A lot of these documents are PDFs, emails, contracts, think comments, tweets, tickets, patent files, application forms. And this data is only going to grow. We see that a lot of organizations have a strong need to make sense of realms of unstructured data. And if you're an organization that is already aware of this problem and you're trying to analyze these documents as part of your business workflows, it's likely you're spending a large amount of time, money, and resources to analyze these documents. And the process may also be error-prone. What if we told you we have a document understanding solution that can help make your life easier without breaking the bank? Hi, everyone. My name is Sudheera Vanguri, and I'm the product manager for Document Understanding AI here at Google Cloud. Today, I'll be walking you through a quick overview of the solution. I'll try to unbundle the solution a little bit, deep dive a little bit into what makes up the solution and the components of the solution. I also have some exciting partner integrations and stories to share with you. I'll also be joined on stage by Anke Conzelmann, the Director of Product Management at Iron Mountain. And she'll be talking about 4 key case studies and vertical solutions that Iron Mountain is investing in. We'll also be joined by Milan, our customer engineer, who will walk us through a demo of a patent application that has been processed end-to-end from unstructured data to structured data using Document Understanding AI. Let's get started. So Document Understanding AI is a solution that enables you to automate key document processing workflows and extract valuable knowledge from within those documents. How do we do that? Well, Document Understanding AI is powered by our powerful natural language capabilities, knowledge capabilities, and vision OCR capabilities. So unbundling and looking through the solution a little bit, we enable you to come into GCP or our partner solutions with unstructured data, a lot of forms, patents, contracts, and all of those, the document goldmine that we referred to a while ago. We enable you to classify those documents, organize those documents meaningfully using our AutoML technologies. We also enable you to extract key value pairs and entities from those documents, again, using a combination of natural language, vision OCR, and our AutoML capabilities. And if a business were to add your own schema, we also have knowledge capabilities through a new alpha version called Knowledge Service. This enables you to construct a knowledge graph out of your unstructured data and map it to your own ERP systems so that you can start to extract insights from those documents and convert that unstructured data into structured data. Let me show you a quick demo.
In this demo, we have a knowledge base that contains Wikipedia articles about a wide variety of topics. In all, there are 48 documents. One of the documents is about steam engines. So here you see the content of the Wikipedia article about steam engines. Now let's say I want to know something about steam engines. We see in our basic search, we have a result that matches on some keywords, but it's not semantically similar to the query. We go to the semantic match. We see that the answer matches the meaning of the query. If we view it in the document, we can see where in the article the passage is coming from. Another one of our articles is about Doctor Who, famous British TV show. Now let's say I want to know the plot of Doctor Who. So I'll enter a semantically similar query. the basic search results, we don't really see who Doctor Who is. But in semantic match, we end up with a great description of Doctor Who. He's a primary character, he's from a different planet, and he goes by the name the Doctor. Now, let's say I want to dive deeper, and I want to answer a specific question. Search result is poor, but we see that the answer to the question is actually in the document. And the answer is 826. 826 Doctor Who installments since 1963. Let's say we want to ask another question. When did it first air? And sure enough, the answer is in the document, and we're able to find it and surface it.
So that's some of our knowledge capabilities for you. Know that we also have a lot of our custom key value pairs and custom knowledge graph building capabilities so that the same use case can apply to various verticals and industries given your business schema. So in a nutshell, what document understanding gives you is through our partner solutions, you'll be able to organize your documents, classify and extract key value pairs and insights from within those documents, and automate your business workflows using the extracted insights. So enough talk, let me dive right into some of our partner solutions, announcing some of our early launch partners. Our lead launch partner is Iron Mountain, which is fully integrated with the document understanding AI solution and our capabilities. We also have key partnerships and integrations with UiPath, Ignite, Box, Taulia, DocuSign, and Accenture. Let's dive right into some key use cases and some exciting examples. Our first partner, Ignite, has used document understanding AI to detect anomalous activity or file downloads on patents, NDAs, and contracts. Now, Ignite Protect enables, an organization or an administrator to know when significant downloads of very sensitive documents have happened over the past couple of weeks. And the way it does that is Ignite Protect builds a personalized profile of the common file types accessed by, let's say, John Smith. Well, that's entirely hypothetical. I don't know a John Smith. Sorry, John Smith. But let's say John Smith accesses a load of patent files, 250-odd patent files within a week, whereas his normal profile typically accesses about 2 to 3 contracts, 4 to 5 patents during a work week. Now, with Document Understanding AI, Ignite Protect is able to classify contracts, employee lists, invoices, NDAs in various document formats and flag sensitive documents when a large file activity happens so that insider attacks and espionage attempts can be thwarted by organizations. That's a cool real-world application of document understanding AI for sensitive document workloads that we see apply to various industries, say HR files, detecting GDPR compliance, so on and so forth. Another partner application of document understanding AI was auto-tagging forms using document understanding AI. DocuSign, our e-transaction management partner, has used document understanding AI to detect bounding boxes on forms. The key use case here, let's say we have a W-9 form. We're able to accurately identify bounding boxes trained on thousands of documents, and also associate those bounding boxes with signature fields, name fields, checkboxes, so on and so forth, to go from an entirely untagged document that was manually tagged before into a fully automatic tagged form that DocuSign then has launched into their mobile application. So I have a cool demo to show you. This doesn't have a talk track, but I'll try to make sense of it for you. So let's say we have an NDA that has a bunch of fields, a set of 5 fields or so, And this NDA needs to be signed by one party. So the sender, let's say Tamara, sends this NDA out to Mattern. Now, auto-tagging kicks in, and we're using document understanding AI, we're automatically able to identify what's a date sign, what's a text field, what's a signature field. Now, we're using a combination of NLP, AutoML, and natural language to do this. That's it. Earlier, this was an entirely manual process that Tamara had to go and identify which fields needed signatures. Using document understanding AI, we are automatically able to identify when a signature, the word signature, is close to a signature field, what is a date sign field versus a leasing date, so on and so forth. So that's document understanding AI, a powerful combination of varied technologies using a combination of NLP, OCR, and our AutoML technologies. Another partner, UiPath, has used document understanding AI for automating their invoice processes. So here's an example of an invoice. As you can see, the invoice is in a tabular format. There is a lot of handwritten text on the invoice. There is a stamp in there. So we're able to accurately identify key value pairs from within that invoice. Taking a closer look at it, as you can see, we also share the confidence scores for the key value pairs that we've extracted from that invoice. Now, if there were a human in the loop, we also enable the human to take a look at the confidence scores so there can be further downstream processing on those invoices. So the entire manual process of invoice processing is fully automated using document understanding AI. A similar use case around invoice processing is cognitive invoicing using document understanding AI that our partner, Talia, has integrated with. Talia uses document understanding AI for automatically extracting invoice data, and using their platform, their suppliers and buyers are able to coordinate on invoices wherever there is verification needed, but then a large part of the invoice processing is automated using document understanding, moving, as Talia says, moving out of the dark ages of manual invoice processing using the AI. Our final partner integration is with Accenture. Saga, an NLP platform powered by document understanding AI and some other key third-party solutions, uses our entity extraction, knowledge graphing, and question answering service to solve key question answering and document understanding workflows for Accenture's customers. With that, let me hand over to Anke for a deep dive on Iron Mountain Insight and 4 key case studies.
Thanks very much. My name is Anke. I am the Director of Product Management for Iron Mountain Insight. And I'm going to tell you a little bit about our platform and some use cases that we're enabling to drive value for our customers. So the office experience, and many of us work with information, we know what this is like, right? There's a ton of data, but finding the right stuff when you need it is incredibly hard still. So this quote, it's from 1982, right? Think about that. So we think it's time to fix it. And our partnership with Google is really all about that. Our customers are at various stages of digital transformation, which for them is about driving value from their information, transforming to a new way of working, and frankly, reducing their risk from the information that they're storing. There are plenty of statistics that actually, she mentioned already, right? So huge amounts of storage, very little of that information actually being used. And document understanding combined with Iron Mountain's information management and information governance expertise really enables us to get to a point where we can, at scale and as a service, deliver the value out of all of that information. And again, I said, we come from sort of an information governance background, so we are also focused on making sure that you can be compliant with regulations that may apply to you as you're doing that. So I'll briefly walk through some high-level information about the platform and then dig into the use cases to show you how that all works. So the platform, there are really sort of 3 steps, if you will, right? First is ingestion. For us, ingestion is really broad, right? So we have customers who store physical information with us, could be paper, could be tapes, and we want to make sure that we can allow them to pull all of that information into the platform in order to enrich it and process it. Could also be digital information, right? So ingestion from various different sources, from various different types of or forms, and in various formats: video, images, documents, all of those various sources that Sudheera mentioned earlier. Second step really then is all about processing that content. We built a cloud-native platform on top of GCP, so we're leveraging all the power of GCP in order to store and process the information. We're using document understanding AI in order to classify and enrich the content. And really, it's all about 3 primary use cases, if you will, at a high level that we want to drive, right? One is around analytics, right? How do I now make this information valuable to a user? The second is around information governance. Now that I know what I have, what are the policies that I need to apply? How long should I keep it? When do I need to protect it because it has personal or sensitive information in it? And then the third one is around workflow automation. And we'll walk through use cases that illustrate each of those items. In the end, it's about adding structure to that big portion of your content that is today unstructured. So the first use case is in oil and gas. So we store incredibly varied types of things for our oil and gas customers. Could be ginormous maps that get scanned and then processed. Could be seismic data that is on tape. Could be well logs that could be dozens to hundreds of feet long. And we help ingest all of that information, and then using the document understanding AI, we extract information that helps us, frankly, enable the geoscientists to make use of this information. So all of the various content, can you imagine if you're a scientist trying to find the information you need to evaluate where you might want to drill or what the value of a certain well is? Right? You're going across paper maps at Iron Mountain, you're going to tape potentially for seismic. And one of the challenges is you just don't ever know whether you actually got access to everything that you need. So what we're doing here is processing the information, again, using document understanding AI. We also can enrich the information with external metadata sources. So it's about pulling as much information, metadata, together from using AI as well as from existing sources and putting that all together in a visual search UI that allows geoscientists to search for it in a way that makes sense, right? So instead of spending half your time looking for the stuff, you can now spend most of your time actually analyzing it. So the search UI allows access by location. So if I'm looking for a certain spot on the map that I want to evaluate, I can get right to the information that's pertinent to me across the various assets that I'm dealing with. We use, for example, a similarity search so that if I see a certain pattern or a sort of intrusion that might be of interest to me, I can quickly find all the assets that have a similar pattern. And all of that really is about faster decision-making and better analysis. Second use case, a bit more sort of text document heavy. In this case, we're dealing with mortgage and really enabling that automation of a very, very manual workflow, right? We all might think that, this stuff is all online now. We fill it all out online. You'd be surprised. Most of it becomes paper somewhere along the line. So it's a very, very heavy manual process. And as a result, it's also a very slow process. So this particular use case is all about, taking a process from multiple days to hours, right? For this particular use case, it's also very illustrative of the power of document understanding AI. What we're doing here is we're looking at a loan file and we're asking two questions. Is it complete and is it accurate, right? So in order to decide whether a mortgage file is complete, I got to understand what documents I got. Classify the documents, compare against a list of per location, what's actually required, right? What defines complete, making sure that all those documents are here. Now we dig in, right? Is it accurate? So this is where we have to pull information, whether it's a name, a social security number, it could be an APR. There are lots and lots and lots of extractions that happen across those different documents. And two things, right? One, do I have everything filled out? Do I have a signature where I'm expecting a signature? Do I have a name where I'm expecting a name? Do I have a stamp from a certain maybe regulatory group that needs to bless something? All of those things need to get checked. Then I need to look across the documents, right? Do I have the same name with the same social security number in all of them? Is the APR the same? And essentially identifying, did somebody put the wrong paper in the wrong file, or is a document filled in incorrectly or incompletely? So document understanding helps us to do all of those things. And then from a workflow automation perspective, we can output that to enable an RPA process that now can be much, much more automated rather than manual. So when you're thinking about, the top of this particular slide, right, all those little people, that's where all the time is being spent. That's where the inefficiency comes in for the processor. That's where the wait time comes in from a customer experience perspective, right? So what we're really looking for here is to drive better customer experience for the actual applicant, as well as time and cost savings for the processor. And then finally, of course, the automation to enable the entire workflow to be automated end to end. The second thing that is really important is once we have all of this rich information, there are other use cases that can be enabled, right? So if a mortgage processor wants to understand how they are doing with respect to compliance for fair lending, right? They have all this rich information that they can now use to understand how they're doing, right? Are they actually well positioned, or do they have an issue, and what can they do about it, right? So the analytics on top, once we've done all of this work, there are a myriad of other use cases that can be enabled for that particular customer. Another very document-centric process is HR, right? So employee records. This particular use case is focused on privacy. So GDPR was mentioned, right? So personal information and complying with GDPR really means you have to be able to understand where you have personal information about your employees in this case, and you have to be able to get to it quickly, right? An employee says, hey, I want to know what you are keeping about me, what personal information you're storing of mine. I need to be able to get to that content quickly. I need to be sure that I'm finding all of it, right? And I need to be able to actually give it to the employee if they ask for it. So processing documents from various sources and in various formats, right? So I've been at Iron Mountain for a really long time. When I first got hired, we filled out paper, right? So my records probably are in paper. So pulling all of that in, being able to image that content and allow that to be commingled with content that may have been collected electronically just a couple of months ago or last year, it's very, very important. And being able to have the ability to understand where that content in the document is and whether or not I'm actually dealing with sensitive information or personal information as opposed to just, here's a big pile of stuff that may or may not be relevant, again, enables companies to not only be compliant but be efficient in responding to requests. So the other thing about these things is you can't keep stuff forever anymore, right? So retention policy, a lot of companies for a long time, actually, kind of the default was, well, I keep everything forever so that way I'm not deleting anything that I shouldn't be. Well, GDPR actually sort of ends the era of everything forever retention policy. So now that we have this information, we have it classified, we understand who it's for. When an employee leaves the company, we have an obligation to actually be able to get rid of that information within the retention period that is within the compliance for the privacy regulation, right? So classifying the content, understanding that it is employee information that pertains to a certain employee now also allows us to get rid of the information when we need to. So that's where the policy plus document understanding AI really, sort of comes together to help companies do the right thing at the right time. This next one I'm going to dig into a little bit deeper. So this is, actually we hear it a lot from our customers. Doesn't really matter what kind of company you are. You probably have customer contracts. We all hope we have many, right? At Iron Mountain, that's something like 400,000. So very simple things get really hard when you're trying to do them across a big, huge pile of stuff like that, right? So first of all, they tend to be kind of distributed. Different products and services, different regions, different acquisitions that they may have come from, right? So the stuff is all over the place. So simple questions like, what are all the contracts for this particular customer? Already hard, right? People poke around in lots of different places and they hope they find all the relevant information, but they may not. The other thing is, things like, well, who has non-standard payment terms? How do you answer that? You get to read a lot of documents, right? That's how it's done today. So then you look at, more complex questions like, which contracts have a limit of liability for data breach above $1 million? And now we're looking at document understanding AI as a really, really powerful tool to allow those natural language questions to actually be answered. So this particular use case is where we worked very closely with Google on using the knowledge capabilities that Sudheera introduced earlier to really empower users to find this type of information very, very quickly. So let me show you a couple of examples that illustrate what the UI looks like and what the experience is for a user. So this is our simple, I need all the contracts for a given customer. Now notice, in this case, we're actually dealing with a salesperson, right? So another thing that is really powerful here is that there are multiple stakeholders potentially within your company that need to access this content. And we can allow each and every one of them to have the benefit of accessing this rich information now very quickly. So in this particular use case, you're going from poking around, asking people, getting to different repositories to essentially one click. What we've done is anything that we extract, we allow you to use as a facet or as a widget. I can pin those on my UI. So if I'm usually looking for things by customer name, I can actually just pin that right to my UI. If I'm looking for a certain customer, start typing in the name or just click on the one that I'm looking for, and all the documents that I need are there with one click, right? So incredibly efficient to get to what still is a fairly simple answer. Second one, a little bit more complex, right? So now, who has non-standard payment terms, right? This is actually quite a common issue for companies, and it's incredibly hard to get to. So again, today, first of all, I got to find all of the contracts in all the repositories, but then how do I figure out what the payment terms are? So I might do a keyword search, and I get to the right section of the contract, which I then get to read, right? So still very manual, very sort of a person doing lots of reading to get to it. Here, what we can do is narrow it down perhaps by customer, if that's what we want to do, narrow it down perhaps by agreement type, so the classification that we've done, but then really looking at the document understanding AI to extract the pertinent information and letting me essentially say, okay, well, you know what, 30 days is my standard payment terms, so anything 60 or 90, give me those, because those are the ones that I need to focus in on. Again, going from who knows how many hours of work to a few clicks that give me the right result set. And this is my favorite one. So when you think about contracts, think about perhaps an M&A scenario. You've just bought a company, your GC walks by and says, hey, how many customers within that population that we've just inherited have a limitation of liability above $1 million? How many do have a non-standard, whatever clause it might be, right? That generally is where, forget your weekend, you're going to be reading for a long time. And frankly, in an M&A case, there is, dozens of people locked into a room for, could be days, could be weeks, depending on how big it is, literally reading through documents. So again, what we can do here is define what is standard, what is non-standard. We can look for those things using the knowledge capabilities that come with the document understanding AI, and extract that information and give it to the lawyers at their fingertips within, again, a few clicks, with the ability to filter based on different types of documents, different regions, if that's what they're looking for. All of that information is literally a click to get to. So I hope these use cases illustrated the power of document understanding AI and what we can do to really drive value for customers from using these types of technologies as part of our platform. We think it's important that we can deliver an end-to-end solution so that customers can really take advantage of all of the benefits that come with these really advanced and great capabilities that Google is providing, and get to a much faster time to value than trying to sort of build it all yourself, build a UI, all of that stuff, infrastructure, all of those good fun things that go around it. So again, the platform, very flexible. We think it's important that you can do that across various content types from various content sources in various formats. We have an example of, for example, the marketing department, right? Those guys are dealing with videos, they're dealing with images, they're dealing with, data sheets, lots of different content types. But when I'm looking for something, it's usually not by document type. It's by topic, it's by, I'm looking for a certain country, for certain languages, for a certain product, but I want all the content for that product or for that language. So again, very important to go across those different formats and types. For us, right, again, defensible, compliant is very important. So we want to make sure that when you're classifying, you're also able to take advantage of that so that you can drive appropriate policy for those documents, right? How do I now leverage the fact that I know what I have, right, and that I can use it, but how do I also make sure that I'm treating it appropriately, that I'm retaining it for as long as I need to, that I'm protecting it because it's sensitive or personal information that I'm dealing with here, and doing that in one platform across multiple stakeholders, across multiple different use cases. So you do all of the hard work once, you classify, you enrich, but then you benefit for multiple stakeholders, multiple use cases, advanced analytics on top once I've done sort of the automation piece to start. So I hope this was helpful and illustrative of what we're trying to do here, and I'm going to pass it over to Milan.
Good afternoon. My name is Milan Lee, and I'm a machine learning specialist at Google Cloud. We've heard already how great the document understanding AI solution really is. Let me go ahead and show you the details of it, the technology of it, and I'll even show you a quick demo on how it works. So for my demo, I'm going to be analyzing patents data. I'll pretend that I'm an attorney at a patent attorney firm, and I want to be able to gain competitive insights on what different companies are doing, what their product innovation roadmap is. And one really good source of that is to look into patents data, patents actually have a lot of rich information that you cannot get anywhere else. You cannot get from journals, you cannot get from conferences. Those are usually pretty proprietary information, but that happens to be shared. So it really helps me to understand what are the active players in the market and for every single product. The challenge of reading through patents is enormous, and let me explain to you what those challenges are and how we can use AI, specifically within document understanding AI, to help us solve the problem. So we're looking at 2 different patents from the US, side by side. For each patent, what's really interesting to a patent attorney is when is a patent filed. And there are various dates within the patent. So we have the date of patent that was approved. And we also have a date for when the patent was initially filed. For me to be automatically extract those 2 key fields are already really worth to use AI for. I want to be able to make sure that when I extract out those fields, I can properly populate them in the database in the exact column and in the exact format and not mix up those 2 dates. We also see a lot of different unstructured data on here. So for example, we have a title of the patent. And the title itself sometimes is pretty generic, but sometimes it's pretty specific. Okay? So I want to be able to extract those key information as well. And of course, there are illustrations within the patents that often tell us what is going on with this invention. What are the components that go towards it? So what if I have an AI tool that can help me to automatically understand and extract out the documents, so then I don't have to manually review it, do data entry for it, and then crop out the image and store it. That would save me a lot of human hours. So this is a pretty huge endeavor to do. And what if I want to really expand this work beyond just US patents? What if I want to start looking at European patents that also come in different format from US? They have different nomenclature, different fields, different titles, different ways of expressing things. And let's go ahead and couple this with the challenge of having different languages. So we can have German, French, in addition to English, and many other European languages. How can we use AI to automate the ingestion, understanding, and processing of all these documents that are in different formats, different languages, and unify them in one single environment? That's really where the AI would come in. Okay, so let me just walk through the life cycle of understanding a patent document. And I want to throw out the caveat that this is not the only life that a patent can adopt. It really depends on what your use case is. But for my use case, what I really want to do is just to ingest data and then process it and be able to store it in a structured format. So let's start off with kind of the ingestion layer. So I want to be able to find an economical option to store all my new patents and be able to archive more old patents. Every year in US alone, there are at least 600,000 patents that are being filed. So we really need a scalable way to store all these patents that are currently in PDF format into a raw storage area. Okay? And this solution doesn't only ingest documents in PDF format. It can ingest pictures, images, videos, so forth and so on. So after we ingest the data, I want to be able to kick out documents that are not looking like patents, right? So in this case, we really want to use a computer vision model to help us fine-tune and kick out those non-patent documents. And then we'll move on to the value-added process, which is to apply OCR on it. So OCR is just an acronym for optical character recognition, which is used to detect and extract the text in an image and then write it out to a raw text format. So why do we need to extract out to a raw text format? So it turns out that there are a lot of natural language processing that we can do on top of this raw text. For example, we can apply a content categorization model. Okay, so what does that do? It will basically scan through the raw text and it will identify what is the topic of this pattern. So instead of me reviewing the pattern manually, now we can use AI to help us understand what the content is. For example, is this pattern about medical technology? Is it about cryptocurrencies? Is it about computer vision, or is it about other things, right? So we can have an AI to automatically understanding for us. And then after that process, we can extract out the specific entities that I'm interested in. So those entities could be the title, the description of the patent, the different dates in the patent. Anything that I want to define as my specific entities, I can basically fine-tune it in my model. And then I want to then do object detection. So the object detection is basically finding the images and signals within an image or PDF document and be able to crop out that image, identify the XY coordinates of that image, and store it in the database. And then lastly, have a structured way to analyze the data. So that's pretty much what I want to go through. Let's go ahead and run a demo really quick. I'm going to log into my system. Okay, so I'm going to launch a shell script. This shell script will basically help me to invoke all the AI services that I will use to generate the classification models, the NLP models, and object detection models. Okay, and then I'll show you the end outcome of it. So I will go ahead and launch the script, and I actually launched it before the demo. Can we go back to the slides? So while this is launching, while the shell script is launching, let me go through what each model is doing. So the first model is basically classifying between the European patent, US patent, and another category called datasheet, which is just more detailed specs about the patent itself. So in order to classify these specific categories, we'll have to use a custom model for it. Because the generic model that Google has as an API will not be specific enough for these three categories. So in my demo, I used roughly 500 samples to train the model, and I was able to get very close to 100% precision and 100% recall for my model performance. Those two metrics are usually used to determine how robust the model is. So with 500 samples, without writing a single line of TensorFlow code, without having to do any programming, I'm able to fine-tune my model to differentiate between the different patents. So this is where I would filter out the data sheets and then move on to the next value-added process. So we apply OCR on it. So as you can see, everything that was inside a patent PDF is now converted to a raw text. That's not really interesting yet. The next interesting part is yet another AI. We wanted to categorize the content within the patent. So by scanning through the content, being able to parse the different sentences, being able to draw semantic meaning from the corpus in the text, we're able to determine what is the category or what is the content for this patent. Okay, so right here in my demo, I only created 3 different categories, but this can be as many categories as you need for your business domain. And again, I only had to train the model with very few samples in order to get this kind of accuracy and precision in my model. So what this is telling me, for example, is every time when I run a model, when I invoke a model, I would be able to get a probability on whether this is a patent relating to medical tech, cryptocurrencies, or computer vision. So given that we know the content, and then we want to extract out the specific entities, this is pretty hard to do. Google has some pre-trained APIs to extract out common entities like objects, names, landmarks, etc., but not really specific to patent documents. So this is where we'll also use AutoML to fine-tune the model and extract out only the information that I want. So remember, this isn't trivial because we have different languages for our patents, and we have different formats. So the positioning of the information might be different among all the patents you have. But with the AutoML, that's within the solution, we are able to fine-tune and extract the exact entity that we need with a pretty high accuracy for most of the fields. And then lastly, we want to draw a bounding box. Again, this is very important to understand the illustration of the invention itself. So the object detection technology will basically identify any objects that you want to identify. So let's say if there are multiple objects here, you can choose to identify the most important object to you and just extract that image with the XY coordinates. And then finally, we saw how we can kind of munch around the unstructured data. And then we finally kind of arrived to the destination, which is to have a very structured way to understand our data. So in this case, I chose to use BigQuery to store all the data. This can be other kinds of analytical database. The destination can be maybe a knowledge service. For example, it can be like this. Okay, so this is within the document solution AI, document understanding AI solution that would help to basically find association and relationship among your data. So, for example, I might have multiple inventors for a particular technology, and I want to be able to find relationships among authors, inventors, or among different content area within my patents. So knowledge service is really helpful visually to find those relationships. Okay.
Thank you, Milan. Before I wrap, quick show of hands. So we've gone through about 7 partner stories. We've gone through 4 key case studies that Anke has pointed out on Iron Mountain and the patent use case. How many of these use cases resonate with some of the document processing workflows you've seen in your company or business? Wow, pretty much everybody's working with contracts, I assume. How many of you have not seen any of these document use cases? Have we missed any? Wow, we got everything? Oh, I see one. Well, I hope that by the end of this session, you're as excited as I am in trying out some of our document understanding capabilities. Our partner integrations make it really easy for you. It's the fastest time to value for you to get these deployments up and running. We see that a lot of companies across verticals, to highlight a few, we see energy companies that try to automate some of the geophysicist workflows and evaluate the risks associated with new sites, use document understanding AI, or can use document understanding AI to identify, let's say, well and reservoir parameters within very technical, geophysical documents that require a lot of ML expertise. Mortgage providers can use document understanding AI to automate and figure out what's a servicing document, what's an origination document. And we've seen that these kind of classifications, not just for mortgage documents, our document classification in general has given over or up to 96% precision. Ignite, for instance, has got 97.3% precision on classifying security documents. Healthcare companies can use document understanding AI in their clinical trial processing. There's a lot of doctors' patient notes that you need to analyze that get very technical, and you may want to analyze, well, what's a dosage amount, or what's influenza, or what's a certain symptom within that patient note. And we see these vertical use cases expand across multiple industries. Contracts, for instance, is omnipresent across multiple verticals, and contract processing is something that all of these industries can analyze using document understanding AI. And retail customers, for instance, can analyze customer feedback. Think tweets, comments, tickets, service tickets that can be analyzed. All of this unstructured data can be converted into structured data using our document understanding AI tools. With that, I'd love to encourage you to try cloud.google.com solutions document understanding. Please visit and provide your feedback. We're always amazed at what new use cases our customers come up with, and sometimes we are surprised by them. So please feel free to give us feedback. I'll hang around for questions, but thank you so much for attending, and hope you try out document understanding AI.